Hi, welcome back. My name is Chandrappa S, lecturer in Mechanical Engineering Program, Government Polytechnic, KGF. In this session, that is in session number 13 of the design of simple machine parts, that is the unit number 4 in machine design in 5th SEM Mechanical Engineering Program. So, in this, we are going to teach different problems on quarter joint. So, let us go for what is further. So, the expected chapter outcomes are like this. So, design of machine elements like solid mouth coupling, flange coupling subjected to direct and twisting moments. So, knuckle joint, quarter joint subjected to direct stress and analyze the various modes of failure with the numerical examples. Come to review of session number 12, what we learned, that is a quarter joint, design parameters of the quarter joint and MCQ. Now, come to contents in this session, that is session number 13. So, we will go for problems on quarter joint and finally test, that is MCQ. Then come to problems. So, come to problem what is given. So, design a quarter joint to connect two mild steel rods for a pull of 30 kN. The maximum permeable stress is 55 MPa in tension, 40 MPa in shear, 70 MPa in crushing. And he is also asking draw the need sketch of the joint design, but need sketch not in this scope, so we have to go for design the quarter joint. Let us go for what is he was given. He is given P is equal to 30 kN, that 30 into 10 to the power of 3 Newton. Sigma T is equal to 55 MPa is nothing but 55 into 55 Newton per millimeter square. Tau is equal to 40 MPa is nothing but 40 Newton per millimeter square. Sigma C is given 70 MPa is nothing but 70 Newton per millimeter square. Now, what we have to design? There is finding parameters are around 11 parameters are there. So, be careful, for every quarter joint these 11 parameters are must. First, let us go for what is that? Diameter of the shaft small d, diameter of the spigot small d1, diameter of the spigot collar small d2, thickness of the quarter T, width of the quarter B, thickness of the spigot collar T1, diameter of the socket capital D1, diameter of the socket collar capital D, thickness of the socket collar L, distance of the rod end to the slot end of the rod, that is L1, thickness of the socket end, that is T2. So, these are the 11 parameters we have to find it out in the quarter joint, that is designing for quarter joint. First thing, that is diameter of the shaft. The diameter of the shaft, considering tearing resistance of the rod, P is equal to formula, that is equation number 4.16a in page number 65. Applying the values, you will get D is equal to 26.35 mm. From the table 3.a from the page number 57 in data handbook, the standard diameter of the shaft can be considered as 28 mm. That is D is equal to 28 mm. For further calculations, we use only 28 mm as a D. Then come to diameter of the spigot. The diameter of the spigot is mentioned in D1 is equal to 1.25 times of D in figure number 4.4 in page number 66 in data handbook. So, by applying the values, we will get D1 is equal to 35 mm. But the diameter of the spigot is subjected to crushing. So, considering crushing, we will get the formula equation number 4.16b, this is page number 65 in data handbook. Applying the values, we will get D1, applying the values, here T we have to calculate, T also will get the equation number, that is the figure number 4.4 in page number 66. Applying these two and substituting, what we will get? P is equal to, as per this, we will get D1 is equal to 41.40 mm. That is by applying what? Crushing. Initially we found 35 mm as per the formula, and by considering crushing, we will get 41.4. And again, considering tension, the equation number 4.16c in page number 65, and T is considered as per the 5 times of D1 in equation number, form figure number 4.4 in page number 66, and substituting, we will get the diameter D1 is equal to 31.91 mm. So, taking the maximum these three, 35, 41.40 and 31.91, we will take 41.40 as the diameter, and the table 3.5a. In page number 57, we will get D1 is equal to 45 as a standard diameter. This is the diameter of the spigot. Come to third one, that is diameter of the spigot collar. So is it D2? Small D2 is 1.5 times of D. This is the figure number 4.4 and page number 66 we will get. Then applying the values we will get D2 is equal to 42 millimeter. But this spigot collar is under crushing. So considering crushing, we will get the equation 4.16D in page number 65. Applying the values, we will get D2 is equal to 50.70 millimeter. But taking the maximum of these two, we will go for 50.70. Yes, 50.70 millimeter. Then from the table 3.5a in page number 57, we will get the standard diameter of 56 millimeter. Now come to 4 point, that is thickness of the quarter. The thickness of the quarter T is given that 0.25 times of D1 in the figure number 4.4 page number 66. Applying the values, we will get T is equal to 11.25 millimeter. Then come to fifth point, that is width of the quarter, that is B. So the B is given by 1.2 times of D1 from the figure 4.4 and page number 66. Then applying the values, you will get B is equal to 56.25 millimeter. Then come to sixth one, that is thickness of the spigot collar, that is T1 is equal to 0.5 times of D1 is a figure from 4.4 into page number 66. Here applying the values, you will get 22.5. But the spigot collar is subjected to shear. Then we are applying the formula equation number 4.16e in page number 65. By applying this, we will get T1 is equal to 5.3. But considering maximum these two, T1 is equal to 22.5 mm can be adapted. Then come to point number 7, that is diameter of socket. As per the figure 4.4 in page number 66, capital D1 is equal to 1.75 times of D, and applying the values you will get 49 millimeter, and also this diameter comes under tearing. Then considering tearing, then formula is like this. That is equation number 4.17a in page number 67. So applying the known parameters, getting the unknown parameters. So we are applying some values as per the given and what we have got from the previous one, and finally we get a quadratic equation like this. So by using the find the roots of quadratic equation method, that is x is equal to minus b plus or minus square root of b square minus 4ac divided by 2a. Same thing can be adopted here to calculate capital D1. So by using that, by using quadratic equation method, then we will calculate the D1, which comes 53.28. Next go for higher value of this even number 54 or 56. If you take more and more diameter, that means a little more diameter, the design will be safe. Then here I consider 56 millimeter. We can adopt 54 also. D1 is equal to 54 millimeter also we can adopt. Then come to point number 8. In this, diameter of the socket collar. The socket collar diameter is given by this capital D is equal to 2 times of D1 from the figure 4.4 page number 56. We found that capital D is equal to 90 millimeter, and also the socket collar comes under crushing by using the formula equation number 4.17b in page number 67 and applying the values. The calculated diameter capital D is equal to 83.09 millimeter. So taking the maximum of these two, the capital D can be adopted is 90 millimeter. Come to point number 9, thickness of the socket collar, that is L is equal to 0.75 times of D from the figure 4.4 page number 66. The calculated L is 21 millimeter. But this socket collar subjected to shearing is also double shearing. Then consider the equation 4.17c and page number 67. We will get the L is equal to 8.33 millimeter. But considering maximum these two, L is equal to 21 mm can be adopted. Then come to point number 10, distance from the end of the slot to the end of the rod. There is a given L1. L1 is equal to 0.75 times of D from the figure 4.4 page number 66. Same thing will be considered. Then L1 we found at 21 millimeter, and this is consider under shearing, then equation number 4.16g, page number 65, then there is a P is equal to 2 into d1 into L1 into tau, then applying the values we will get L1 is equal to 8.33 millimeter. So considering maximum these two, we will get L1 is equal to 21 millimeter. Then last point, there is thickness of the socket, that is T2 is 0.5 times of D. Applying the values, then we will get that T2 is equal to 14 millimeter, and this is subjected to shearing. Then applying the equation number 4.17e, page number 65, we will get the value T2 is equal to 8.52 mm, but maximum of these two values, that is T2 is equal to 14 mm, can be adapted. So these are the some of the values which should be found out and in different conditions. As for the formula also we can find out from the figure 4.4 in page number 66, and by considering what type of loads acting on these elements and considering the maximum value, then we will find out the values of the different parameters. Next, problem number 2, that is two rods end of the pump are joined by means of a cotter and spigot and socket at the ends. Design the joint for an axial load of 100 kN, which is alternatively changes the tensile and compressive. Both the relative changes to tensile and compressive. The allowable stresses for the material used is 15 MPa in tension, 40 MPa in shear, and 100 MPa in crushing. Let's go for writing what he was given. The given parameters P is equal to 100 kN, converted Newton, 110 to the power of 3 Newton. Sigma T 50 MPa is nothing but 50 Newton per millimeter square. Tau is equal to 40 MPa, nothing but 40 Newton per millimeter square. Sigma C, the crushing stress is 100 MPa, is nothing but 100 Newton per millimeter square. And here, what to find? We have to design. The finding parameters are diameter of the shaft D, diameter of the spigot D1, diameter of the spigot collar D2, thickness of the cotter T, width of the cotter B, thickness of the spigot collar T1, diameter of the socket capital D1, diameter of the socket collar capital D, thickness of the socket collar L, distance from the end of the slot to the end of the rod, there is L1, thickness of the socket end is nothing but T2, as mentioned in the previous problem. Same parameters should be found here and same procedure. Go for first one, diameter of the shaft. Considering tearing resistance, equation number 4.16a, page number 65, applying the values, you will get D is equal to 50.46 millimeter. But standard diameter should be applied, adopted here. Then from the table 3.5a in page number 57, the standard diameter of the shaft can be adopted is 56 millimeter. Then come to second point, diameter of the spigot, that is D1. The D1 is equal to 1.25 times A as per the figure mentioned in 4.4 in page number 66. Calculate the diameter D1, it found 70 millimeter. Then this spigot diameter comes under crushing. Then considering crushing, we can get the equation 4.16b in page number 65. Applying the values, calculated diameter D1 is equal to, applying the values before that you need unknown parameter T. T is equal to 0.25 times of D1. And substituting these values, and we will get D1 is equal to 63.24. Previous case, that means applying from the figure we will get 70 mm. Applying the crushing we will get 63.24, and this diameter of the spigot considering tension, that is the equation number 4.1c and page number 65, and applying T is equal to 0.25 times of D1 and from the figure 4.4 in page number 66. Then substituting, you will get D1 is equal to 61.11 millimeter. Previously it is first case 70 millimeter, and by crushing we will get 63.24, and by considering tension we will get 61.11. But maximum this is 70 millimeter. Then the maximum value is from the table 3.5a and page number 57. The standard diameter is 71 can be adopted. So this is the diameter of the spigot. Then come to third one, diameter of the spigot column, that is D2. D2 is equal to, as per the figure we calculate 1.5d, and applying values these we get a D2 is equal to 84 millimeter, and this spigot collar comes under crushing, and the equation number 4.16D and page number 65, we will get the equation like this, that is P is equal to pi by 4 dt square minus d1 square to sigma c. Applying the values, we will get d2 is equal to 79.46 millimeter. But we have to take maximum of these two, that is d2 is equal to 84 millimeter by table number 3.5a and page number 57. The standard diameter of the spigot collar is 90 millimeter. The upper value of the standard diameter, that is d2 is equal to 90 millimeter. Here we have to go for shaft diameter, spigot diameter, like that we will go for the standard diameters, but should be standards. Then point number 4. What is that? Thickness of the quarter, that is T is equal to 0.25 times of D1 as per the figure 4.4, will get 17.75 millimeter, and also width of the quarter is B is equal to 1.25 times of D1 from the figure 4.4, and we will get the B is equal to 88.75, and sixth one is thickness of the spigot collar, that is T1 is equal to 0.5 times of the D1 from the figure 4.4 in page number 66, and also we will get the 35.5, but this thickness of the spigot collar comes under shear, then there is a P is equal to pi d1 t1 into there is equation number 4.16e in the page number 65. Applying the values, we will get t1 is equal to 11.2, but considering the maximum value of these two, we will get 35.50 millimeter is the value of thickness of spigot collar, that is 35.5. Then come to 7th one, diameter of socket. Diameter of the socket is capital D1 is given by 1.75D from the figure 4.4 in page number 66, and applying the values we will get D1 is equal to 98 millimeter. But this socket comes under tearing, then considering the equation number 4.17a and page number 67 and applying the known values to calculate capital D1. By applying the known values, we will get like this, and finally the quadratic equation D1 square minus 22.61 D1 minus 5985.91 is equal to 0. By applying find out the roots of quadratic equation method, calculate the value of D1, that is the maximum value. By applying the quadratic equation method, we will get the capital D1 is equal to 89.49 millimeter. Then the maximum value and rounding up, I took 100 millimeter. You can choose 90 millimeter also, no problem, but upper even values. Here I took 100 mm for my safer side. Then 8th point, diameter of the socket collar, that is capital D. As per the figure 4.4 page number 66, the value is D is equal to 2D1, and applying the values we will get 142 millimeter. But this socket collar comes under crushing. Then using the equation number 4.17b in page number 67, then the value of the capital D becomes 127.33. So here we get the maximum value D is equal to 142 millimeter, then the adopted value should be 142 millimeter. Then come to 9th point, the thickness of the socket collar, that is L, small l, that is 0.75 times of D as per the figure 4.4 in page number 66, and this L will be found 42 millimeter, but this L comes under shearing. And considering shearing, P is equal to 2 into D minus D1 into L into tau, the equation number 4.17c, then we will get the value of L is equal to 17.6, and considering maximum of these two values, that is L is equal to 42 millimeter. Then come to 10th point, distance from the end of the slot to the end of the rod. So here we will get L1 is equal to 0.75 times of D, as per the figure 4.4 in page number 66. Calculated value is 42 millimeter, but this comes under shearing. Then considering the P is equal to 2 D1 L1 tau, that is equation number 4.16g and page number 65, then you will get the value of L1 is equal to 17.6 millimeter. By considering maximum value, L1 is equal to 42 mm can be adopted. Then thickness of the socket end, that is T2 is equal to 0.5 times of D from the figure 4.4 into page number 66. Applying the values, you will get 28 millimeter, and also this T2 comes under shearing. Considering shearing, there is the equation number 4.17e and page number 65. We will get the value of T2 is equal to 14.21, but considering the maximum value, the value of T2 will be 28 millimeter. So these are the parameters should be, we have to find it out. Now the 11 parameters completed. So this is the end of the problem. And also we'll come to multiple choice questions. Before that, I need to tell something for you. Here we have calculated the values of different parameters by using the figure 4.4, that is the quarter joint, and also calculated based upon the equations. By observing the equations and the equations provided in the figure 4.4, the maximum values are coming only by the figure values, that means mentioned in the parameters in figure. So calculating by using formulas, that is equations, the value becomes lesser. So in your examinations, by considering the equations present in figure 4.4, it's good enough. For getting the different values by using different stresses, because they are mentioned the stresses, the stresses has to be considered, then you have to conclude the maximum value. Don't go for calculating the parameters by using figure. Use the figure values, no problem, but using the allowable stresses, calculate what is the remaining values. Compare these two values, get the maximum value and put it in the figure. Then you will get the full marks during examinations. Now come to multiple choice questions. Question number 1. Quarter joint can be used to connect two rods for torque transmission. Is right? Let's go for answer. Disagree? Agree. Quarter joints not used for torque transmission, it is used for axial, that is tensile and compressive. Then the answer must be option A, that is disagree. Question number 2. Quarter joint is connected to option number parallel, perpendicular, coaxial, inclined. In the starting itself, that is in the previous session, I told it has to be connected coaxial. Then the option is C, that is coaxial. Then come to question number 3. Taper is made quarter and slot on both the sides. But in the theory I mentioned sometimes both the sides, but normally they will not be used. Then it is only single side. Then the question both the sides is false statement. Okay, only one side has been provided. Then these key answers are question number 1 A, question number 2 C, question number 3 B. And this is the end of the session number 13. And this is our LMS team. Thank you for listening this session, and we'll meet in session number 14, that is last session of the chapter 4, that is unit number 4.